In this video, we are about to demonstrate our smart temperature system. So, firstly, why do we need this system? Um, as we know, like currently the temperature, the weather actually that changes so frequently. Definitely, that cause variation in temperature too. So this increases the usage of heating and cooling appliances. And in this busy life, people often forget to switch off the appliances. So this system is basically designed for such peoples. So what our system will do, it will keep your house at normal temperature. Here we used a DHT22 temperature sensor. This will We are going to use two temperature sensors. One is for sensing the outside temperature of the house, the temperature outside the house. Another one is the temperature inside the house. And further, the comparison will be made between the temperature sensed by outside sensor and the temperature sensed by inside sensor. On the basis of that comparison, the decision will be taken. Either the appliance has to be trigger on or off. So this is the demonstration of our prototype. So this is the Arduino board attached with which Arduino shield is attached. So this is that one sensor which is outside the house, and the currently LED is on. It means that the appliance is on, and this one is the inside sensor. So here is how are the roles of our group members. Jasmeet Singh, he works as a uh, developer, Devesh as a researcher in this project, and me as a data handler and tester. So here is our so these are the requirements of our system. Before designing, what were the requirements of our system? So the first thing is how sensing of how sensing works for the temperature. Like, and how comparison will be made between the both data sets, the data collected from outside and the inside. So of course the requirements, this one is saying that we need sensors, like how we sense the temperature. To sense temperature, definitely there is the need of sensor. And the other thing is we were required with the hardware of low cost, of course, as we are just designing the prototype. So uh, I don't think so that we need to spend more money, but it must be better. The other thing is that how data will be stored and how it will be refined. So these are the things that were needed, like in hardware, all things like the Arduino board, the shield, SD cards, all that stuff that we use, the like the temperature sensors, and moreover the things like their frequency, like if after one reading, after taking one reading, after how much time they take another reading. I mean, how much seconds they take to take another reading, like after 1 second or two, so the time gap. So those things were too about to consider while in this requirements. And then moving on to the design path, the things were like how our hardware should be more durable, because in our system we are we were placing one of the temperature sensor outside the house. So outside the house, as we know, the temperature varies, and moreover, climatic conditions those vary, like uh, raining and in all that uh, environment, our sensor must work. So that must be durable. So that's why hardware should be more durable. We included this thing in the design, and moreover, its accuracy at which place they are placed. Like suppose if we place a sensor to the wall, just closer to the wall, or the wall, or a glass wall, definitely the temperature will be higher there, closer to the wall, in comparison to the temperature a little far from the wall. So that thing too has to be considered while placing the temperature sensor, where we are placing that, either too closer to the wall or to the position, to that position where it is accurately telling us what is the exact temperature of the outside environment. Because as in, like, suppose if in like glasses, if we talk about the glass got even cold to uh like very quickly, I mean to say. So that can influence, that can affect the working of the temperature sensor. Maybe sensor will sense wrong data. So that's why the position must be accurate, and moreover the connections should be neat and tidy, of course. If your connections are good, it means the current, the electricity that will pass through them, that wouldn't damage the system. Of course, sometimes uh like if unfortunately, like if there's a pass of more electricity than needed, then that can damage the system. And now moving on to the implementation part, the system is created in such a way that it will collect both the temperatures inside and outside, right? Now in implementation, we write the code. So in the code, all the conditions are mentioned, like on the basis of what um temperature the appliance has to be turned on or off. So this decision will be made in the case on the basis of, on the comparison of those two data sets that we were collecting. And other thing is data will be saved. So here we are using SD card to save the data. And in testing, we as we like we checked out all those things we mentioned in the code. Like if the outside and inside minimum temperature is equal and above 25, then it should be off. I mean, the appliance should be off, right? Here we are using LED, so that means that LED should be off. So if the inside temperature is 7 degrees lower than the outside, then it should be on to manage the temperature. So if the inside temperature is high, then our outside one, like if the temperature inside the house is higher than the outside temperature, then it will turn off the appliance. So well, this is all about the testing. So we tested this by measuring the temperature outside inside with the other devices, and then check that out, either LED is responding right or wrong. This is the burn down chart. uh, we planned in this way, but our graph got little distorted at the last moment. It is because of our device, one of our device that got damaged at the last moment while testing. So that caused this delay than the estimated time. So it takes little more time than the estimated time. So this is how our burn down chart. So the code to the link to the code is here. So code can be checked. I don't think so that it need. So here is our data, the data that we collected. So this is the inside temperature, and this one is the outside temperature. Like here, the status of the LED is on in these four readings, because here the inside temperature is more than yeah, it is more than 25, 25.50, 60. It's when here 26. But when it become equal to 25 and goes on lesser and lesser and less, then the status turned to be off. So this is all our collected data. Like sometimes the status turn on and off. It depends upon the code you have written. So yeah, these are the photos of our system. Outside, inside the room, temperature, the motion sensor. Sorry, the temperature sensor. So this is our Arduino with the Arduino shield over it, and there SD card and LED that is used at the place of the heating appliance. So this is the diagram of our system. Here is our Arduino, the brain that's gonna work. So this is our outside sensor. This is our inside sensor. Here is the wall. So basically, this Arduino is gonna do all the work. It's gonna compare both the data sets of collected by this sensor and that sensor, and then gonna take the decision either the appliance have to turn on or off. It means either the LED has to be on or off. So these are the few challenges that we faced while making this system. The most difficult challenge we faced was how comparison of both data sets will be done. That is, of course, the part of code, but that needs to be like that got more attention. The another challenge was that the stability and placing the outside sensor for stability and durability. Again, because the varying environmental conditions are hereby influencing. Those were like sometimes it's such raining, so that were causing issues. So this was the another challenge. Also, a challenge arise of storing data in which manner and the values required. So like if we talk about like the stability of this one is basically the temperature sensors we were using, those were better, but as I told you that at the last moment the temperature sensor stopped working. So that was to the challenge. uh, so that because sometimes the temperature sensors they sense but not accurately, or sometimes they need time to stabilize. Like if we take a temperature sensor from inside the house and outside, then maybe it will take time. Some will take time, some don't take time, but some sensors take time to stabilize in that environment and then start taking the accurate reading. So this was the challenge that we faced. This was, I think, the big issue that we faced in comparison to other ones, even bigger than the comparison of both data sets.